When pricing electrical work, especially for specialized tasks like wiring a 3-zone boiler, several factors should be taken into consideration. Ignoring these factors can lead to undercharging, which ultimately devalues your services and can negatively impact the market. Let's explore these factors in detail. Firstly, there's the labor cost. Electricians typically charge an hourly rate that reflects their skill, experience, and overhead. In the Massachusetts area, this rate generally falls between $75 and $150 per hour. This range accounts for the electrician's expertise, insurance, tools, and other business expenses. Secondly, travel time is a significant factor, particularly when the project is located far from your base of operation. The time spent traveling to and from the job site is time that cannot be spent on other billable projects. Therefore, it's essential to factor in the cost of travel time, including fuel, vehicle wear and tear, and the electrician's hourly rate for the time spent traveling. Thirdly, weekend premium. If the project is scheduled for a weekend, it's common practice to charge a premium fee. Working on weekends often involves sacrificing personal time and may disrupt an electrician's work-life balance. This premium compensates for the inconvenience and reflects the increased demand for services outside of regular business hours. Fourthly, the complexity of the project is another crucial consideration. Wiring a new 3-zone boiler can be a complex task involving multiple circuits, control systems, and safety requirements. The more complex the project, the more time and skill it will require, justifying a higher price. To determine a reasonable price range, let's consider a hypothetical scenario. Suppose the project requires approximately 6 hours of labor. At the low end of the hourly rate range, $75 per hour, the labor cost would be $450. Adding $100 for travel expenses, the low end of the price range would be $550. At the high end of the hourly rate range, $125 per hour, the labor cost would be $750. Adding $100 for travel and a $200 weekend premium, the high end of the price range would be $1,050. Therefore, a reasonable price range for this project could be estimated between $550 and $1,050. Now, let's analyze a specific pricing scenario where an electrician quoted $600 for wiring a 3-zone boiler located an hour away from the home, scheduled for a Saturday. This price falls within the reasonable range, considering the following. Firstly, the electrician is charging slightly above the low end for labor. Secondly, they are including the travel time in their estimate. Thirdly, they are not charging a weekend premium. If a plumber objects to this price, claiming it's double what they expected, it may be due to their own unrealistic expectations or a lack of understanding of the factors involved in electrical work. It's important to explain to the plumber the factors that have been considered and encourage them to understand the value of professional electrical services. If you were to accept a price significantly lower than the reasonable range, it could potentially diminish the value of electrical services in the area. It could also create a situation where other electricians feel pressure to lower their rates in order to compete. This race to the bottom can ultimately harm the industry and lead to lower quality work. It is important to stand by your price, especially if it's based on a thorough assessment of the factors involved and falls within a reasonable range. Explain your pricing to the client. Communicate the value of your expertise. Encourage the client to understand the factors that contribute to the cost of electrical services. By standing firm on your price, you are not only protecting your own interests but also contributing to the overall value and professionalism of the electrical trade. Remember that pricing electrical work is not just about covering your costs. It's also about reflecting the value of your skills, experience, and expertise. By carefully considering all the relevant factors and communicating your value effectively, you can ensure that you are being fairly compensated for your work while providing your clients with high-quality electrical services. Let's delve deeper into some of the technical aspects of wiring a 3-zone boiler, which contribute to the complexity and therefore the pricing of the job. Firstly, understanding the control system. Modern boilers often utilize sophisticated control systems to manage the different zones, water temperature, and overall efficiency. These systems may involve programmable logic controllers, or PLCs, sensors, and various control modules. The electrician needs to be familiar with these systems and how they interact with the boiler's electrical components. Secondly, wiring the circulator pumps. Each zone in the boiler system typically has its own circulator pump to circulate hot water through the radiators or baseboards in that zone. These pumps require proper wiring, including correctly sized conductors, overcurrent protection, and grounding. The electrician needs to ensure that the wiring meets all applicable electrical codes and safety standards. Thirdly, integrating with thermostats. The boiler system needs to be integrated with the thermostats in each zone to allow for individual temperature control. This may involve wiring low voltage circuits to the thermostats and connecting them to the boiler's control system. The electrician needs to understand how the thermostats communicate with the boiler and ensure that the wiring is properly installed to prevent any malfunctions. Fourthly, safety considerations. Working with electrical systems always involves inherent safety risks. Electricians need to be aware of these risks and take appropriate precautions to protect themselves and others. This includes wearing appropriate personal protective equipment, PPE, such as gloves and safety glasses, and following safe work practices, such as de-energizing circuits before working on them. Fifthly, code compliance. All electrical work must comply with the National Electrical Code, NEC, and any local electrical codes. The electrician needs to be familiar with these codes and ensure that the wiring is installed in accordance with them. This includes using the correct types of conductors, properly sizing overcurrent protection devices, and grounding the system in accordance with code requirements. When providing a quote for wiring a 3-zone boiler, it's important to consider all of these technical aspects and the time and effort required to complete the job safely and correctly. A thorough understanding of the system and attention to detail are essential to ensuring a successful and reliable installation. Let's talk about specific code sections that might apply to this installation. While I can't provide an exhaustive list without knowing the specifics of the installation, here are some relevant areas of the National Electrical Code that an electrician would typically reference. Firstly, Article 300 covers wiring methods. This article dictates how conductors should be installed, supported, and protected. It includes requirements for conduit, cable types, and general wiring practices. For example, Section 300.11 addresses securing and supporting wiring. Secondly, Article 310 covers conductors for general wiring. This article deals with conductor ampacity, insulation types, and allowable uses. Table 310.16, for instance, provides ampacity ratings for conductors based on insulation type and temperature rating. Thirdly, Article 430 covers motors, motor circuits, and controllers. Since circulator pumps are essentially motors, this article is highly relevant. It includes requirements for motor overcurrent protection, disconnecting means, and conductor sizing. Section 430.22, for example, addresses the minimum conductor ampacity for motor circuits. Fourthly, Article 450 covers transformers. If the boiler system uses any transformers, this article applies. It includes requirements for transformer overcurrent protection, grounding, and installation. Fifthly, Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Low-voltage control wiring for thermostats and control systems often falls under this article. It outlines requirements for conductor types, overcurrent protection, and wiring methods. Sixthly, Article 250 covers grounding and bonding. Proper grounding and bonding are crucial for electrical safety. This article provides detailed requirements for grounding electrodes, equipment, grounding conductors, and bonding of metallic parts. It is important to remember that the NEC is a comprehensive document, and electricians need to consult the specific sections that apply to their particular installation. Local codes may also have additional requirements or amendments to the NEC. A thorough understanding of these codes is essential for ensuring a safe and code-compliant installation. Beyond the code, let's consider some best practices for wiring a 3-zone boiler to ensure a reliable and efficient system. Firstly, proper labeling. Clearly label all wires, circuits, and components to facilitate future troubleshooting and maintenance. Use a permanent labeling system that will withstand the heat and humidity of the boiler room environment. Secondly, neat and organized wiring. Keep the wiring neat, organized, and properly supported. Avoid loose or dangling wires, which can be a safety hazard and make it difficult to trace circuits. Use cable ties, clamps, and other supports to keep the wiring secure and tidy. Thirdly, using high-quality components. Use only high-quality electrical components that are rated for the intended application. This includes conductors, connectors, switches, and overcurrent protection devices. Avoid using cheap or substandard components which can fail prematurely and compromise the reliability of the system. Fourthly, proper grounding. Ensure that the system is properly grounded in accordance with the NEC. This is essential for electrical safety and helps to prevent electrical shock hazards. Use a dedicated grounding electrode conductor and connect it to the building's grounding system. Fifthly, testing and commissioning. After completing the wiring, thoroughly test the system to ensure that it is functioning properly. This includes checking the voltage, current, and resistance of all circuits. Also, verify that the thermostats are communicating correctly with the boiler and that the circulator pumps are operating as intended. By following these best practices, electricians can ensure that the 3-zone boiler system is wired safely, reliably, and efficiently. This will not only protect the occupants of the building but also enhance the reputation of the electrician and contribute to the overall quality of electrical services in the area. Finally, let's consider the importance of continuing education for electricians. The electrical industry is constantly evolving, with new technologies, codes, and best practices emerging all the time. To stay up to date and provide the best possible service to their clients, electricians need to invest in continuing education. This can include attending seminars, workshops, and online courses. It can also involve reading industry publications and participating in professional organizations. Continuing education not only enhances an electrician's technical skills but also helps them to stay informed about changes in the NEC and other relevant regulations. This is essential for ensuring code compliance and avoiding costly mistakes. Furthermore, continuing education can help electricians to specialize in certain areas of electrical work, such as renewable energy, home automation, or industrial controls. This can open up new opportunities and allow them to command higher rates for their services. By committing to continuing education, electricians can demonstrate their professionalism and dedication to providing high-quality electrical services. This will not only benefit their clients but also enhance their own careers and contribute to the overall advancement of the electrical industry. In the specific scenario of pricing the wiring of a 3-zone boiler, taking all these factors into account allows the electrician to justify their price, negotiate effectively with the client, and ultimately deliver a valuable service that is both safe and code compliant. It's about more than just pulling wires, it's about understanding the system, applying technical knowledge, and adhering to professional standards.